We are going to see the cross product for each component when we cross each vector, a vector A with vector B, for example. When we do the cross product, we are going to see it here in detail and to know how or where this formula comes from. So the vector A can be expressed as A1, A2, A3, but also as A1 I plus A2 J plus A3 K. Also for B, B1 I plus B2 J plus B3 K. So when we do A cross B, actually we are crossing each component with each component and adding the same way that we did in the dot product. We dot each component with the other, just that when we dot, for example, A1 with A1I with B2J, I dot J, because the angular 90 degrees is always, all these were dying because it was 0. The only that counts were just the i's, that is I dot I, J dot J, and K dot K. So for that, in the dot product, we just multiply this and add them. In the cross product, it's going to be different, and so we are going to find that formula in the cross product. Alright, so first, let's do cross of each vector, each component with the other components. So I will put 3 rows, one for A1 cross the others, the second for A2 cross the others, and the third for A3 cross the others. So A1 will be A1 I cross B1 I plus A2, plus A1 I cross B2J plus I plus AI cross B3K plus now the second component, A2I dot A cross B1I plus plus A2J A2J cross B2J plus A2J cross B3K plus A3K cross B1I plus A3K cross B2J plus A3K cross B3K. Alright, so we have this corresponds to the row of A1, A2, A3. Also, this corresponds to the row of the I's. This corresponds to the row of the J's. And this corresponds to the row of the K's. This corresponds to the column of B1, B1, B1. This corresponds to the column of B2, B2, B2. And this is the column of B3, B3, B3. Also, you could see I's, J, and K. Alright, so now, when we have I cross I, or J cross J, or K cross K, all these are 0. Because remember that the definition of the cross product is magnitude is magnitude of A times magnitude of B times the sign between these two vectors, the sign of the angle between the two vectors. Here, I cross I is just 1 times the sign of the angle between I and I. These are at 0 degrees, so sine of 0 degrees is just 0, and so each one of these would be 0. I cross I, J cross J, and K cross K are 0. Next point. When we have I cross J, I and J are at 90 degrees angle. So we have now a resultant vector that is orthogonal to both these two orthogonal vectors. So the result is K. So, but how do you know if it is K or negative K? Because K and negative K are both orthogonal to both of these two, and they have exactly the same direction, just the sense is opposite. So you write I, J, K. If you do I cross J, you have K. If you do J cross K, you have I. So J cross K is equal to I. Next, if you do K cross I, you have J. K cross I, you have J. Now the opposite. If you go from J cross I, J cross I is minus K. Next, I cross K. I cross K will be minus J. And I cross K, now J cross K, K cross J, K cross J is minus I. Alright, so let's just see this in each cross that we're going to do. So again, we have A1I cross B1I. This is 0. This is 0, 0. A2J cross B2J is 0. And A3K cross B3K is 0 because K cross K is 0. So this line is 0. Next, you have A1, B2, and I cross J. So I cross J, that's K. So you have A1, magnitude of A1 times magnitude of B2. So A1, well, that here is magnitude is just that number because each component is not a vector. We are not talking about tensors. We will talk of this in other videos. So here it would be just A1, B2, K plus I cross K is minus J. Yes, I cross K. With I cross K is minus J. So minus A2, B3. J. Next is J cross I, that's minus K. So I have A2 B1, well, minus A2 B1 K. J cross K, that's I. So plus A2 B3 I. Next, wait, I think I made a mistake here. What did I do here? I cross K. Sorry, here is A1. Sorry, going A1's row. So next, K cross I, that's J. So A3 B1 J. K cross J, that's minus I. So minus A3 B2 I. Alright, and now let's group the I terms, J terms, and K terms. So we have I is these two, so it's A2 B3 minus A3 B2 I. Plus now J, here is negative J, and I'm looking for the positive J. So A3 B1 minus A1 B3 J plus now K I1 B2 K minus A2 B1 sorry, K at the end, minus A2 B1 K. So now let's put in not adding, so in components. So we have A cross B is equal to the vector I. In the I component we have A2 B3 minus B, A3 B2. In the J component we have A3 B1 minus A1 B3, and in the K component we have A1 B2 with A1 B2 minus A2 B1. So that's the cross product. In the cross product, you can, if you want to know A cross B, you will just put in the, well, you know that A cross B is a vector that is perpendicular to each one of these two, and is a vector as opposed to the dot product. The dot product, also called scalar product, is just exactly or literally adding terms, so it's just a number. Cross product is a vector. So in the I component you put the subtraction of well, first notice that in the I component you have components, second and third components of A and B. You just have 2's and 3's. In the J you have 3's and 1's, and in the K you have 1's and 2's. You begin with A2. You know that you in the I you know that you're going to have A2, and A3. You begin with the lesser number, so you begin with A2. So you know it will be A2 B3 minus vice versa A3 B2. Next, in the J, if this began with A2, this began now with A3, and so A3 B1 minus vice versa A1 B3. And in the K, if this was A3 and this was A2, the only option is begin with A1. So A1 B2 minus A2 B1. Alright, so like that you can calculate the cross product of vector A times cross vector B. There is other way to do this, that is alright, let's erase all this. The other way is you take the determinant of a 3 by 3 matrix. That 3 by 3 matrix is going to be I J K. Next, one of the vectors I1, I2, I3, and B1, B2, B3, and you take the determinant. The determinant of the matrix of a 3 by 3 matrix, there is many ways to do it. One, you copy these two rows here, or the other is if you already have done a lot of exercises in matrix multiplication, you can do it now. I think that the faster way, but the difficulty to remember. So it needs a lot of exercises already been done. So, but I think that I have never showed you this method, so I will do it. And also it's my favorite, but it was the difficulty for me to memorize. So, it is this, remember that I did this plus this plus this minus this plus this plus this. This is the last one. So the other way is this, that is A2 B3 I plus now this, what's next? This, that is A3 B1 J, and you can see it, if I copy the row I A1 B1, this is what's followed, B1 here. Next, plus I did this, next this times this 2, if I copy here J A2 B2, next is this K A1 B2, K I1 B2 A1 B2, so plus A1 B2 K minus this times this 2, this I1 B3 J, the same as this times this 2 I1 B3 J. So I will put it in here minus, let me remove the sharp thing. No, so minus what A1 B3 J plus, that this plus is inside the parentheses, so at the end would be minus this times this, and what's next? This. So is this A3 B2 A3 B2 I plus the last one A2 B1 A2 B1 K. And now you group the terms. So again, in the I we have this and this. this, and this. So it's A2 B3 minus A3 B2. A3 B2. Next, in the J, we have A3 B1, A3 B1 minus A1 B3. And in the last one, we have A1 B2, A1 B2 minus A2 B1, A2 B1. So it's exactly the same. For that, when we do cross product of two vectors, we usually take the determinant of the matrix 3 by 3 that is composed in the first row of just the unit vector of the coordinate axis, and the second rows are the components of each vector. But it's exactly the same as if you memorize this formula and you do it. Now, what the important issue was to know how we arrived to this formula, to know how we are crossing i's and j, and which are the corresponding vector with the sign, that is with the sense. Our issue is that the cross product is a vector as opposed to the dot product that is a scalar. And remember that the cross product is magnitude of A times magnitude of B times the sign of the angle between those two. But actually, when we say it like this, it is incomplete, because this just looks like a scalar number, like the dot product, just that instead of multiplying by cosine of theta, you're multiplying by sine of theta. But actually you have a vector, not a scalar. That is, you need to multiply this times the unit vector in the direction of the orthogonal vector that is orthogonal to these two. I think that the better example is in when you do torque, when we are talking about torque in physics, you have the vector of the distance, you have the center of the mass that could be here, or could be, for example, here, and when you apply a force, you do torque, or here do torque, or if this is the center of mass, here you do torque. You have one vector that is the vector in which you are applying the force. You have a second vector that is the vector of the force, that the force could be applied at 90 degrees angle, at 45 degrees angle, or less. And the cross product of this vector and the force vector is going to be magnitude of this times magnitude of the force vector times the sine of the angle between them. Obviously, the greatest torque is when the angle is 90 degrees, because the maximum sine of theta is in 90 degrees. That's 1. And so the maximum would be when the vector of the force is perpendicular to this vector, and when it is parallel, you are not doing any torque. Also, the torque is proportional to the distance. It's not the same to do this as to do this. I cannot move it. And it's not the same to apply this force as to apply a greater force. So it's proportional to the magnitude of this vector, magnitude of A, magnitude of B, the force vector, and the sine of the angle between them. But the result is, if you think about keys in the bathroom, when we wash our hands, that key in the bathroom, you put a force, could be this, to this vector, or this, but this third vector is moving. It rotates like this or like this, and so the key is opened or is closed. So you have vector A, vector B, and a third vector that is orthogonal to both. Here is orthogonal to vector A. It's also orthogonal to vector B. So the cross product produces a third vector that is orthogonal to the previous two.